Hello everyone, in this video I'm going to be doing a disassembly of the BMW i3 air conditioning compressor. So this is the one which has just come out in my car, and because I suspect that it's the compressor that's blown, I've actually already ordered another second-hand one just to take its place. So I'm going to disassemble this and then report back to Hunter at Ace Auto Centre with my findings. So let's see what we've got. This probably isn't going to be that easy to get out. Yep, going to need a bit more than that. Yep, the head is just stripped right off that. Yeah, that's pretty bad. So there's no chance of getting this thing back together again. Head just going straight off. Brilliant, fantastic engineering. In BMW's defence, this compressor wasn't made by them, but it was no doubt chosen by them. Yeah, this is going to require some fighting. Yeah, that one's just snapped straight off as well. Absolutely horrifying. It's just seized in with rust. Now I don't know if they're not attached anyway, so I don't know if there's no really any way I could free these up. I think they're all just going to snap off, so I'm just going to snap the rest of those off and we'll go from there. Well, this one came out. I thought maybe, oh, these could be left-hand thread, but they're not. They're just ruined. So let's see. Yep, snap. Absolute garbage. I wonder who made this. Made by Vistion Portuguesa. So yeah, trash. Anyway, let's continue. This will not be going back together again. Right, now I just need to get something sharp to separate that with. Okay, maybe not. So, first we've got to do the smell test, see if we can smell anything burned. No, I cannot smell anything suspect in there at all. So what we have here is the inverter board, obviously. I can see a current sensor there already, so I'd imagine it would have current limiting to, sort of prevent fuses from blowing. So I cannot see anything alarming in there. So I'm going to try and take this apart and see what I can find. So obviously going to be a three-phase motor in here, and lots of other stuff. I'll probably find the IGBTs for the inverter underneath here somewhere as well. Don't know, there's maybe some gate drivers there, but there's no use speculating. The more I take this apart, the more I'll be able to find out. So the windings are going to be separate, they're going to be sealed off from this board, I think. So if it's the windings that have burnt out, then, well, I'd imagine it would have temperature sensors as well to even protect from that. So this is beginning to confirm my suspicions that it's maybe not actually the compressor that's gone. But nevertheless, the thing's a piece of garbage anyway. So we're just trying to take out all these screws. Okay, screws out. I wonder if this will just pull off. So let's see. I don't think it is. I don't want to pull it by that transformer either. That's some sort of isolation transformer there of some description. But we just need to very, very carefully pry this off. Be very gentle. Could still be stuck at that connection. Still 2 screws. Okay, bicycle tyre lever, here we go. If I can just get that in there. Obviously I don't want to break this board, so it's going to just require a lot of very gentle fiddling around, unless they've gone and done the unthinkable, which is they've put this board in and then they've soldered it. So there's connections here which, so the solder is actually holding this board on, in which case I'll need to get out the soldering iron and take that off, because I don't know what those are connected to. I don't know what are the windings, so there's not really much point in putting a multimeter on it at the moment, but I cannot seem to get that out, so I think the soldering iron, the solder sucker, needs to come out for this. Oh, here's another idea. Well, sucking the solder would just blow it away, because solder sucker is just not cutting it. It's a little puff of air really is what you need. It just comes away, no problem. So we'll just have to check for any solder which is splattered on the other side. But yeah, that's cleared those up really nicely. So that should come out easily enough. Okay, so now the question is, will it come away? I certainly do not suggest the compressed air method for getting rid of solder like that. For anything you're wanting to put back together again and have work, because it could just blow solder into places it's not meant to. So this may just lift off. Well, still 2 there. Okay, I finally managed to get the PCB out of this piece of garbage, and here it is. Fairly simple. Got 2 Hall effect current sensors, so they're just sensing the currents on 2 of the 3 phases. I could repurpose those easily for a high voltage low power VESC, which I want to make for a generator, depending on their current handling capacity, of course. And just flip this over to the other side. We'll have gate drivers and stuff on this side. It's fairly simple. It's about as complex as a standard VESC motor controller really, probably just with some extra isolation. So not much to see there. There's a main current sensor here, and that's maybe for overload detection, I don't know. That looks like a weird implementation of a fuse using the PCB, that thing with all the holes in it. But yeah, we then turn our attention to this H-bridge, so 3-phase H-bridge. Those are probably IGBTs, AU4062D-E. IR, so it's made by International Rectifier, which is now Infineon, I believe. I think that thing there, what could this be? I'm just trying to figure this out. I really don't know. I don't know if it's being used as a switch, just to switch the power onto everything. I don't know, so it could be a MOSFET or IGBT they're using for that, but when I put this up to the light, I can't see any sort of thick power traces going to where that would be, so it seems unlikely. So let's get the multimeter on the phases. Here's the phases going to the motor in here. They will probably be quite low resistance, I'd imagine, so I might not be able to detect anything, so we'll see if we've got any shorts to ground. We're getting something, I think we're getting something here. So between this phase, 239 kilo ohms, so there's an insulation failure anyway. Yeah, 240 kilo ohms. This one here, yeah, it's 240 kilo ohms to the ground. So this is all the 12 volt ground. The high voltage ground doesn't normally touch the 12 volt ground are kept separate for various safety reasons. I don't know what our phase to phase resistances are going to be. 0.27 ohms, 0.53 ohms, 0.46 ohms. Yeah, so usually you would expect them all to be the same regardless of whether the motor is wound in delta or star. Unless, well, it can't be, that's the only connections we've got to go into the motor. So for a fun little experiment, I'm going to try and connect a brushless motor controller up to this. Not a VESC or anything fancy like that. I'm just going to find a cheap motor controller which I have lying around and see what happens. Okay, so that's rather messy setup as the compressor connected up to a large electric scooter controller. So let's just power this up. And as you can see, it's sort of just jumping. There is enough voltage there to move it, but it's like something shorted inside, or there's a mechanical problem, because yeah, just that's all it's able to do. Thump slightly. So the resistance readings we got between two of the phases being lower than the rest, or one of the phases being higher, suggests that there is definitely something wrong here. So I'm going to take apart the rest of the compressor and see if I can see anything. I've just checked all these IGBTs with the multimeter and none of them seem to be shorted, so that's slightly worrying. Maybe these are really strong and can take a lot of abuse, but I find it unlikely that a 400 volt 80 amp fuse is going to blow before these do. Okay, so I just took a grinder to this thing and cut through all the bolts, because the bolts are just absolutely ruined. They're just seized in. So oil's all black, and it's like there's metal fragments that have just sort of been mashed in. So this compressor is yeah, it's toast. I don't know what the motor windings look like yet, but I'm going to try and take it apart a bit more and see if I can find the windings. Probably not going to be that easy to see, but we'll find out. Okay, so this is quite difficult to show, but you can kind of see inside there that there's burned windings, so I reckon it's likely that this compressor has caused the 80 amp fuse to blow. It's just really strange how it hasn't actually blown the IGBTs, which I showed earlier. So yeah, you could see that the windings are pretty charred. There's black oil and metal fragments and stuff inside this, so it's likely this is the culprit. So what it suggests to me is that the whole thing failed while I was charging and preconditioning at work. So maybe the failure current of this compressor trying to start up, it probably tries to start itself for some reason, I don't know. It started itself up while the PTC heater was running. The PTC heater's 5 kilowatts, and obviously added to that, this with a short circuit inside has probably blown the fuse. But now we need to establish the root cause of the leak, which is going to be another thing altogether. Okay, so just a few end notes for the video. This thing is not actually a MOSFET as I thought it would be for switching the thing on. That would have been obvious because it's only got 2 legs. This is just a resistor. So it's an 18 kilo ohm 5% resistor, a ceramic resistor, just shaped like a MOSFET, and it was heat sunk to the casing. So that's quite interesting. I'm not too sure what that's for. There's just a connector for the CAN bus or whatever was controlling this, and here's the high voltage connector. The interesting thing about that is it's not actually got high voltage interlock loop pins inside it. Those are perhaps inside this connector. So yeah, that was a horribly designed thing that I did not enjoy taking that apart at all. Numerous design faults. The main one is that there's no over temperature protection by the looks of things. It's quite weird that it managed to burn out like that. It should have had temperature sensors on the windings, but oh well, that's just me.